What up, your boy C Rizzy coming at you with Unit 9, Lesson 3, Rotations. Our essential question is how can you represent a transformation in the coordinate plane? And our objective is to draw and identify rotation images of a figure. So rotations preserve distance, angle measures, and orientation of figures. So rotations just also preserve size and shape, so it's a rigid motion. So a rotation of x degrees about a point Q, which is called the center of rotation, is a transformation with the following properties. And again, this all has to do around rigid motion. So basically it says the distance from the pre-image point to the center of rotation and the center of rotation to the image point would be equidistant. The number of degrees a figure rotates is the angle of rotation. A rotation about a point is a rigid motion, and you write the x degree notation of a triangle about point Q as the following. R, which the lowercase r, which stands for rotation, how many degrees, comma, around what is the center of rotation, which is normally around the origin of the triangle, results in triangle U prime, V prime, W prime. And unless otherwise stated, all rotations are counterclockwise. Okay, so here's the rules for rotations. So if I were to rotate a point 90 degrees counterclockwise about the origin, the xy point would change to negative y, comma, x. So the points would switch and the y value would change sign. A rotation 180 degrees, which is also a reflection about the origin, just changes the signs of the xy points. And a rotation 270 degrees counterclockwise becomes y comma negative x. Now one thing to pay attention to, 90 degrees counterclockwise is the same thing as 270 degrees clockwise. And 270 degrees counterclockwise is the same as 90 degrees clockwise. So if you think about it, going counterclockwise 270 degrees is the same thing as going 90 degrees clockwise. Going 90 degrees counterclockwise would be the same thing as going 270 degrees clockwise. And a 180 rotation is exactly the same. Okay, so here's just an example of how the points change. So this is a counterclockwise rotation of 90 degrees, which means xy is becoming, let's just double check, negative yx. So you can see in each example how the points switch and then the y value comes negative. It's hard to see in p prime and q prime, but with r prime you notice 4, 1 becomes 1, 4, and the 1 becomes negative. So that's how they do that, and then they plot them and then they connect the vertices. So let's do an example here. So we're rotating FGHI 270 degrees counterclockwise. So FGHI, which is going to be our XY point, and we're going to rotate that 270, which is y comma negative x. I'm pretty sure. I'm just going to double check. 270, y comma negative x. So F is at negative 3, 2. G is at negative 3, negative 1. It was nice for him to put the points there. H is negative 1, negative 1. And I is 0, 1, 1. So now I'm going to change these points. So now 3, negative 2. So what I usually do is I just switch the points first and then change the sign. So I'm changing the x value, so the negative 3 becomes positive 3. Change the values, and the x value becomes positive. Switch them, x value becomes positive. Switch them, x value becomes positive. Or change the sign and it's 0, so that doesn't change sign. So those are our new points, and I'm going to plot them. So this is f prime is going to be at 2, 3. F prime. G prime is at negative 1, positive 3. G prime. H prime is at negative 1, 1. H prime. And I prime is at 1, 0. And then we connect And if you ever wonder whether you did it right, okay, this is a 270 degrees counterclockwise. So if you're ever wondering, did I do this right? What you do is you connect your original points to the origin and then to the back to the pre-image. And notice that this is a, I'm going to pick a different color. The angle that I created going this way is a right angle that's 90 degrees clockwise, which is the same thing as 270 counterclockwise. So we know we rotated that correctly. Alright, that was a quick video. That's all for me.